The objective today is to explain how a network interface card works. This is essentially part 2 of a two-part series of network interface cards. I just really like these little pieces of hardware. Or at least I really enjoyed learning about all there is to learn about these things. They're so much more complicated than I initially thought. So if you didn't watch the first one, I'll quickly go through a review of everything we talked about in that first one, and then I need to zero in on some information about ROM's purpose on the network interface card. Then I have a funny serving analogy for you. You can probably tell I'm going to talk about servers somehow in this analogy. Then some details on the concept of a network interface card being a gatekeeper. Then you need to know about a cool tool called Wireshark. This is very useful. Then I'll talk about some indicator lights on the NICs, purchasing factors when you go to buy one, talk about server NICs in particular, and I'll finish with a security blurb. And then as you walk out of this lesson, you could be over learning about network interface cards. So here's my introduction. Part 1 was quite a bit of information, especially if you hadn't known much about a NIC in the first place. So before you listen to anything I have to say in my review, write down what you remember. So pause right here, write down everything you can remember, and then take a deep breath as I review, as I go through this process. Last time we talked about how a network interface card on a cell phone is actually just part of the SoC chip, the software on a chip. The NIC inside a cell phone will still connect to an antenna, and then I made the joke about SoCs, this not being the same kind of SoC. However, for the lesson, we zeroed in on the network interface cards that are on motherboards. I just tried to refer to this concept more throughout the lesson. So on a motherboard, you could take a NIC like this, and you would plug it into an interface that accepts that. Maybe you're looking at a different kind of connection, which is totally possible, but when you start seeing ports like this that go to RJ11 or RJ45 ports, you can usually bet that that thing is well, not usually, always. If there's these ports, these things are being connected to a network interface card somehow, some way. This is a picture of a small network interface card that goes inside of a smaller laptop. This is the antenna connection, and here is it changes the ones and zeros coming in from the antenna into ones and zeros that go onto the motherboard this way. After that, I showed this picture, so pause here if you really want to soak that in and enjoy it. I needed to identify the difference between a driver and a NIC in the first place. A NIC is the hardware, and we call things that make the hardware, the NIC hardware work, we call the software drivers. Because if we're talking networks, computers talking to each other, these ones and zeros have to be driven from one place to the other, I suppose. Then I explained once a frame comes into a network interface card, the part of it is chopped off, the MAC address part. So certain ports are blocked. You will not be accepting that message, even if it is lying, or maybe, if it's telling the truth that your computer is the MAC address it's looking for, even if that may be true, but it's trying to communicate on a port that you have blocked, that communication will stop right there. You already probably see where I'm going with this in terms of that gatekeeper thing I alluded to in the table of contents. Here's a great picture if you don't remember what a frame is and the difference between a frame and a packet. Here's the packet, here's the frame. A lot of people get these confused. We talked about the MAC address right here. It says MAC. That address is in a hexadecimal format. IP addresses usually are not. You can spoof a MAC. That's tricky, and I'm not going to teach you that. The MAC actually stands for Media Access Control, so that's another important idea we talked about. This X should be moved over a little bit because MAC addresses are made up of 48 bits. These MAC addresses are on every single device that is intended to communicate on a network. So whether it's a small IoT device like a thermostat or a giant server, computers have to have MACs. The other thing I mentioned in the last lesson is there are 3 ways for the network interface card to start processing the information it's hearing or it's getting. One way is if there's an exact match of the MAC address of that computer. The second way is if there's this broadcast address. So if something's screaming FFFFF, okay, that's a broadcast message and all computers will be listening at that time. Doesn't necessarily mean anything will get through, but it will be listening and that data will move to the next step. Another nifty way to get a computer to listen always is through a promiscuous mode. You don't want to be in that mode unless you know what you're doing. If you're looking at this word list from last time and you know what all of these mean, you're ready for what I'm about to tell you. So let's begin. The new stuff. The Nic's MAC address is called the burned in address. So you might see BIA. Man, in technology, we love to just make acronyms of everything. So this burned in address, this MAC address, is actually on a ROM chip. So we have RAM, which is a very temporary thing. We have ROM, which is a very not temporary thing. And then we have human. Maybe depending on the human, it will be either more like a ROM or a RAM. If you're a person who easily forgets things, maybe you got a lot more RAM in your mind. Okay, that's probably not a connection I should make, but this next analogy is a connection I should make for you Star Trek fans. ROM is a character from Star Trek, and this is not the ROM I'm talking about, but a good connection is that they both are servers. They're serving something. ROM works at Quark's bar. The ROM on the NIC is serving a MAC address to your computer and the computers that it's trying to communicate with. So for the rest of your life, you should be able to remember what a ROM chip is good for, long-term storage, and a ROM chip on a NIC card is storing the MAC address. So when the NIC is getting data in, when this type of connection occurs that's a BIA match, an exact MAC address match, we call this a unicast frame because there is only one computer, get it, uni, in the world that this frame can be for. And in that sense, the NIC is a type of gateway or gatekeeper. Let's review that real quick, what I just said. How does a NIC act as a gatekeeper? Use your vocabulary in the answer and you are more likely to remember this because you want to be able to talk about these things in class with me, especially when we start experimenting with this tool called Wireshark. When you are in promiscuous mode, the gatekeeper is essentially turned off. This option is used when you are using tools like Wireshark, when you're using a protocol analyzer or packet sniffer. You're listening to all the traffic that is in the air or on particular wires that you're hooked into. And by the way, Wireshark is not just for finding performance problems, which is a big point of taking this class. You can also find other things. Not ready to teach you much about that yet, though. Let's go into the lights that you may see blinking on your network interface card. Many NICs have indicator lights to show information such as if a link is established and or if an activity is happening. You might see different color lights to indicate if the speed is 100 megabits per second or 1000 megabits per second. This information may be useful to you at any given time, so you can just look at the side of your laptop or the back of the computer maybe if it's accessible, and then you can see these lights and you'll know what's going on in the inside of your computer. Now, there are some decision-making factors for you to think about when you go to buy a NIC. You may want a faster one. You may need to choose a particular bus interface so that it connects to the type of computer you have. Also, you'll need to choose the correct NIC driver for the operating system you have. Not all operating systems accept all NIC drivers. Now, with servers, if you have a NIC card on a server, you're looking at having an onboard memory, and then you're going to see a lot more ports. I mean, this one just has 2, so depending on your server, and this type right here, it's called dual port PCI Express Gigabit Ethernet Server Adapter Network Card Intel i350 NIC. Yeah, that's a beefy one for something that's experiencing a lot of traffic. Now, wireless NICs often support a variety of standards, so we're talking everything from 802.11 ABGN. The connection for these are established using what's called a Service Set Identifier, SSID, which you can name whatever you'd like, and I've seen some pretty funny names in my time, but some are obviously out there to trick people on purpose, and you don't want to connect to those. Just a quick FYI, although it might make sense to name the SSID something easily identifiable, like the company name or the address you're at, that might not be the best idea either. This is especially true if the network is in a shared building or in close proximity to other buildings or network. Now, if you have the option, you might also want to be in enterprise mode of WPA2 format. WPA2 is so far the most secure. I heard about WPA3, but at the making of this video, I don't know if it's available. But the nice thing about enterprise mode with WPA2 is it will authenticate people individually. So when you go to log in, you have a username and password to use. So here's your DOL. We had a big beefy part of review there, and then I threw in some more information for you. So I just want you to add to your answer from last time. Just describe to me how network interface cards work using some new words here. And don't forget extra credit if you can use all the words here.